next video, we will talk about our physical properties for alkenes and cycloalkenes. And like was mentioned in the very first video, our physical properties are going to be very similar to what they were for alkanes, in that they are less dense than water, insoluble in water. The melting point for an alkene is usually going to be lower than the alkane that has the same number of carbon atoms. And the main reason for that is you do have a slightly smaller molecule by having 2 fewer hydrogens. So your London forces are going to be a little bit weaker. So your alkenes are a little bit easier to pull away from each other. Melting points for your branched alkenes are going to be lower than the straight chain alkene with the same number of carbons, also just like they were for alkanes. And then something new, because we have cis and trans, is cis alkenes are going to be slightly lower than trans alkenes. And in the next examples, I'll help you see why. So here's a comparison for gas and liquid, at what point we switch. So for alkenes, unbranched, your C2, 3, and 4 are gases, and then when you get to longer 5 and up, you're liquids. For cycloalkenes, the smallest we have is 3, but still 3 and 4 are going to be gases, 5, 6, and up are going to be liquids. So here's some examples where we're going to compare two and decide which has the higher melting point. So we've got cis-3 heptene. So when I'm drawing cis double bonds, I like to start with the double bond and make sure my 2 carbon groups are coming the same side of that double bond. Here I know carbon 3 is the start of the double bond. So if that's 3, this one's 2, so there's 1. So 1, 2, 3, 4, here's 5, 6, 7 to make the heptene. The next option is trans 3 heptene, so 1, 2, 3, 4, 5, 6, 7. Double bond between 3 and 4. And if you just do the zigzag, you'll easily get the trans. So here the difference is cis versus trans. We saw in the earlier slide that cis is usually lower, so that means the trans will have the higher. And the reason for this is the stackability, if you will. So your trans molecules are going to stack pretty easily because they're relatively flat. When you have a cis double bond, that puts kind of a kink in your molecule, so they are less stackable, so they're easier to separate from each other, so they will have the lower melting point. So that is why cis is lower than trans. Next examples, we have 3-methyl-2-hexene. So methyl is on 3. There's your double bond, versus heptene. And it doesn't really matter where the double bond is. It doesn't say, so we're assuming that it's the first spot. But we're going from branched to linear. And branched is lower, so linear is higher. So heptene will have the higher melting point. Last example, we are comparing 2-methylpentene to 2-methylpentane. So it's the alkene versus the alkane, and we just said alkanes tend to have the higher melting points. So those are your physical properties. Big thing is be able to tell the higher and lower melting point if you're given a pair of structures based on the CHEMs. The next section, we'll be looking at one way to make an alkene from an alkane, doing a reaction called dehydration.